There are primarily two methods by which we can analyze the control system. The one is transfer function approach and the other one is state variable approach. Initially, we will consider transfer function and concepts related to it, and in later lectures we will cover state variable approach. The transfer function of a linear time invariant differential equation system is defined as the ratio of the Laplace transform of output to the Laplace transform of the input under the assumption that all initial conditions of the system are 0. Even though in the definition it is written Laplace transform only, but you should always remember that we will be taking the unilateral Laplace transform of the signals. We can have the expression for transfer function equal to ys divided by xs, which are the Laplace transform of output and input. Now suppose if xs, which is the Laplace transform of the input, is equal to 1, then the transfer function will simply becomes equal to Laplace transform of the output. And we also know that the unilateral Laplace transform of impulse function is equal to 1. Therefore, transfer function can also be defined as the Laplace transform of the impulse response of the system under the assumption that all initial conditions are 0. The term impulse response refers to the output of the system when the input is impulse signal. It is very important to understand each and every word of this definition, otherwise there are chances that you may commit silly mistakes in the question. We have already seen what are linear and time invariant systems earlier. Hopefully you also know what is a differential equation. There is a separate chapter in mathematics which deals with differential equations only. You are supposed to study that also for competitive exams. And the most important point in this definition is all initial conditions are 0. It is very clear that we are talking about the system. Suppose that we have two systems. In both these systems, we have two metallic bars and in between them there is an elastic band attached to them. But in the first case, we have elastic band which is unstressed, whereas in the second case, we have stressed elastic band which is joined at the floor with a hook which releases the elastic band whenever an object comes within 2 cm of its radius. Now suppose a ball is dropped from a certain height and we have to find what will be the height up to which it will bounce back after being hit with elastic band. In the first case, there is no energy stored within the elastic band. However, in the second case, the elastic band is stressed, therefore consisting of elastic energy, such that we cannot apply the transfer function approach in the second system, whereas the transfer function approach can be easily applied in the first system. The statement all initial conditions are 0 practically means that there should not be any stored energy within the system priorly when an input is applied. Differential equations of LTI systems have constant coefficients only. We will understand this point with 3 examples. This is a very simple example where all the coefficients are numbers. This differential equation is an easy example representing LTI system. Now consider the second example. In this example, the second term on the left hand side of this equation consists of multiplication of output and its derivative, which is not allowed for a linear differential equation. Therefore, this equation may be time invariant, but it is definitely not linear. Therefore, we can say this differential equation does not represent an LTI system. Now consider the third example. The second term on the left hand side has the differential of output is being multiplied by input, which is not allowed for time variant system. Also, the third term on the left hand side of this equation where output is multiplied by t square, which is also not allowed for time invariant system. Therefore, this differential equation also does not represent an LTI system. Now, try to solve a very simple question within 60 seconds. This question was easy because it was very straightforward. But what if the question is same but the language used is little bit tricky? Suppose that the question is little bit modified such that the question becomes, if the following differential equations represent different control systems, then which of these system equations cannot be solved through transfer function approach? To solve such type of questions, it is very important for you to clearly remember the definition as well as all the properties of transfer function. Otherwise, in the exam, you will not be able to analyze what you are actually supposed to do to find out the answer. The properties of transfer function can be divided into advantages, disadvantages, and characteristics. The advantages of transfer function are: it gives simple mathematical algebraic expression, it gives poles and zeros of the system directly, and also the stability of the system can be determined easily. Transfer function is independent of the input of the system. Disadvantages of transfer function are: it is applicable only for LTI systems. It does not consider the initial conditions of the system. Analysis of multiple input multiple output system is quite lengthy. Controllability and observability cannot be determined. Except the fourth point, I guess all the points are clear. And in the previous question, we have used only the first point of disadvantages. You will understand the fourth disadvantage in the upcoming lectures. Just write it in your short notes for now. One very important characteristic of transfer function is that the transfer function of continuous data system is expressed as a function of complex variable s, whereas the transfer function of discrete data systems, which are modeled by difference equations, is generally expressed as a function of z. This is probably the only point which you have to keep in mind regarding discrete data type systems, because in this series of lectures we are going to consider only continuous data type systems. You will be studying discrete data type systems in signals and systems, but here in control systems we will not consider them. For competitive exams of graduate level, discrete data systems in control systems are not considered. Well, if we put advantages, disadvantages, and the characteristics of transfer function all together, then we will get the properties of transfer function. In European countries, the last letter of the English alphabet is pronounced as Z, whereas in Asian countries it is usually called as Z. So don't get confused, both are actually the same thing.